Let's have a look now at simplifying algebraic fractions. And rather than sort of going through some theory to begin with, I'm going to just talk about some of these strategies as we go through some of these examples together. But basically what we're going to do is factorize what we can using the usual methods. And we try and then cancel these factors, either cancel vertically or diagonally, depending on the operations that are involved. So let's have a look at the first one. I'm going to simplify the fraction 4 minus 2a over a squared minus 2a. So the first thing I'm going to do is let's factorize this first. So I'm just going to save a little bit of space. I'm just going to write it this way first. So we can apply common factorization first. So we can take out a 2 from the numerator, and that's going to be 2 minus a over the denominator. We can factorize out a, okay, and that's going to be a minus 2. Now that's almost well and good. We could almost cancel the brackets, in fact, but it would have been nice if we had either a minus 2 in common or 2 minus a in common. So in the numerator, on the numerator actually, I'm going to turn the positive 2 into a negative, and then I'm going to switch the 2 and the negative a around. And the reason for that is I would like this a here to be a positive. I want this positive 2 to be negative. So I'm going to flip the signs inside the brackets, but to compensate for that, I need to flip the sign of the term outside of the brackets. So I'm going to turn the 2 into a negative 2, but then I'm going to turn the 2 inside the brackets into a negative, and then the negative a into a positive. So that's going to become a minus 2 over a outside of a minus 2. Now the brackets are identical. I can cancel vertically, and I will get negative 2 over a as the simplified fraction. Okay, let's have a look at part B. And I might use some different colors here just so that makes it a bit easier to read. So everything's going to be, I anticipate a bit of an algebraic mess, which I'll try and avoid wherever possible, but on these boards it's not always easy. A squared b over ab squared. In fact, there's quite a few common factors there. In fact, if you wanted to factorize it, you could, I guess. So if you took out sort of ab from the numerator there, and then that leaves an a inside of the brackets, over, again, take ab out as a common factor, and that leaves b inside of the brackets. So the ab, in fact, cancel, and then you end up with a over b. Nice and easy. Okay, so what about the next one? Okay, x squared minus 1 over x plus 1. What do you think? Now you can see there from the numerator there that it looks like a difference of 2 squares. So why don't we factorize the numerator first? Okay, so x squared minus 1 could be expressed in factor form as x squared plus 1 multiplied by, x plus 1 multiplied by x minus 1, okay, over x plus 1. So we have a factor in the numerator cancelling with a factor in the denominator, which are identical, and that leaves us with x minus 1. Okay, so a simplified version of x squared minus 1 over x plus 1. Now, let's have a look at part D. So x squared minus x minus 6 over x squared minus 10x plus 21. So this one, well, two quadratics, all right, so it's one quadratic divided by another quadratic. Probably makes sense to just factorize them both. They're both monic quadratics, so hopefully fairly straightforward. We can find some nice factors to represent these quadratics. Okay, so if we represent them in factor form, x squared minus x minus 6, so we can think of maybe x minus 3, okay, x plus 2, okay, which is the factorized version of x squared minus x minus 6, okay, over x squared minus 10x plus 21. So I can think of negative 7, negative 3, okay, or negative 3, negative 7. I'll write it in that order. You'll see why shortly. Okay, you can see there that I've got two brackets, one in the numerator, one in the denominator, that I could just cancel directly because they're identical, and that leaves us x plus 2 over x minus 7. You can, of course, if you want to check this answer, I'm actually going to show you this little trick. I guess it's not a comprehensive, surefire method of checking to see if you got the answer right, but it's a fairly fast way of checking reasonably accurately whether you got the right answer or not. I'll show you this little nifty little thing you can do. Okay, so I might just increase the brightness there a little bit. Okay. What you do is you give x a value. I don't know, just make up some number. Let's say, I don't know, 10, something different other than the numbers that you see. I'll make it 11. So what we do, if we store that in memory, so 11, shift STO X. Okay, so shift STO X. Then what we're going to do is we're going to enter in this expression. Okay, so we're going to type it in fact. So alpha x squared minus x minus 6 over x squared minus 10x plus 21. And you get 13 on 4. Let's see if we get 13 on 4 with our simplified version there, a simplified fraction. So x plus 2 over x minus 7. And we get 13 on 4. I'm reasonably confident, I wouldn't say I'm 100% confident, but reasonably confident that I'm basically 99.9% correct. So in an exam situation, this is not a bad little tactic, and it will save you a lot of time and will almost guarantee that you've got the right answer. When I say almost, you could fluke it, put a value for x in, like some value that happens to give you the same answer, but doesn't mean that you've actually factorized it and simplified it correctly. Let's have a look at part E now. Okay, so part E involves a non-monic quadratic divided by a monic quadratic. So we can factorize this, again, the usual kind of way. Okay, so in fact, I'll just need a little bit of space there, so I might just erase that. Okay, so let's factorize the numerator. Now, 5 and 2 are prime numbers, and that's actually a very useful little property, in fact. So we're going to have a 5k and a k here. And we've also got to have a sort of a 2 and a 1, or a negative 2 and a positive 1, or something like that. I want a positive 9k there, so I'm going to make this positive 2. Why is that? Because I can see a 10k here, and I'm going to make this negative 1 because I'm going to subtract off 1k to give me 9k. All right. So when you, practice these non-monic quadratic factorizations, hopefully you'll be able to get that fast at it that you don't actually need to use the cross method, or in fact grouping with pairs. You could just almost write it directly, okay? And then you could sort of in your mind just multiply it out, and you'll sort of get that answer over. Okay. If you find that method was obviously far too fast for you, that's fine. For the time being, by all means, use the grouping in pairs method, use the cross method, okay? And then once you feel more confident with that, obviously you can speed things up a little bit later on, okay? So these things require some patience and do require some commitment, okay, on your part to become good at them, like anything, I guess. K squared plus 7k plus 2, let's factorize that one. Two numbers that when multiplied give you 2. I think there's a, let me just check, I think there's a, maybe there's a problem with this one, I'm not sure, let me just check. Sorry, I just found a problem. That actually should be a 10. I was thinking, hang on, that's not going to work. So, sorry about that. I'm just going to make that a 10 there. Ah, that's better. Sorry. When I was coming up with these questions, I sometimes, I'll come up with them and I think, oh, hang on a moment. When I come to do them, oh, it doesn't work. Right. Okay. You'll probably find that yourself. And think, oh, hang on, I can't factorize that one. Well, it's not an easy way to factorize it. Okay, k squared plus 7k plus 10. Aha, that's probably better. Two numbers that multiply to give you 10, but then when you add them together, you get 7. Thank you, I get 5 and 2. So let's write that down. So we get k plus 5, lowercase k, and k plus 5, k plus 2. Okay, make sure I try to make them lowercase k's because that's what they are. Okay, and we can go, we'll cross them out. All right, that's sort of top and bottom, and we end up with 5k minus 1 over k plus 5. Again, we can do our little trick with the calculator to check that works, but I'm not going to spend the time. You can do that yourself. All right, let's have a look at part F. Okay, x minus y minus x squared over x plus y. Ooh, what's going on here? Looks like we got some what appears to be sort of like whole numbers or sort of minus a fraction. Okay, so in fact, what we could do is we could treat x minus y as a fraction. Okay, so maybe over 1. And then we need a common denominator of sorts. So if I multiply this first fraction by x plus y over x plus y, I should then get a common denominator. Then I can just add and subtract the numerators, after we get our common denominator. So why don't we do that? So that's going to be, x plus y over x plus y. I'll show all the working out here. Multiplied by x minus y over 1 minus x squared over x plus y. Okay, so now look at the numerators there. So I've got x plus y multiplied by x minus y. Looks familiar? They look like conjugates of each other, don't they? That's a difference of 2 squares, isn't it? So that's going to be x squared minus y squared, okay, over x plus y minus x squared over x plus y, and then we can subtract the numerators directly. So x squared minus y squared minus x squared. In fact, that disappears, and in fact, that disappears, and then you end up with negative y squared over x plus y. Okay. So again, what was the strategy here? Anytime you have whole numbers, okay, or just pronumerals on their own, treat them as a fraction by putting them over 1. All right. Part G. X squared on x squared plus 3x plus 2 plus 2x on x plus 2. Again, we need a common denominator. All right. So the way we're going to work that out is let's factorize the first the first denominator here, and work out kind of what's missing in the second denominator, and then maybe multiply it through, and let's hope we get something that's going to work. Okay. So I just need a little bit of space here. Okay, so let's factorize the first denominator. So we have x squared in the numerator over now x squared plus 3x plus 2, two numbers that when you multiply gives you 2, and add them you get 3. It's a not nice, well-behaved monic quadratic. So that's going to be x plus 2, x plus 1, okay, plus 2x over x plus 2. Now it would be great if I had an x plus 1 here as well. So therefore the denominators would be common. Well, let's do that. So what we're going to do is we're going to multiply top and bottom here by x plus 1 over x plus 1. That's kind of like find the factor that's missing and then multiply it in. And that way you sort of reintroduce that factor into the denominator, into the respective denominator, and that way you end up with two denominators that are in fact common. So that becomes x squared over x plus 2, x plus 1, plus, now let's multiply this through. You've got 2x, okay, outside of x plus 1 over x plus 2, x plus 1. Right, now we have two fractions, common denominators. We can just add the numerators together. So I'm just going to go one more step here and just simplify the second numerator. So that's going to be x squared. In fact, I'll just put them all on one common denominator now, actually, couldn't I? X squared plus 2x squared. Okay, so that's 2x squared plus 2x all over. In fact, rather than writing it as x plus 2, x plus 1, I could just write it as the quadratic again, couldn't I? So x squared plus 3x plus 2. I don't think there's anything there that we can cross out. So let's have a look. That's going to give us no, it won't actually. So we get 3x squared plus 2x. Okay. Over, let's have a look here. X squared plus 3x plus 2. Okay. We could factorize out. Yeah, we could factorize out the x, I guess. If you want to express it in fully factored form, let's leave it in fully factored form, in fact. So I'm just going to go back a little bit here. Okay. because there's a chance here that maybe there could be something here that might, that might sort of cancel top and bottom. So let me just leave it as x plus 2, x plus 1. Okay, so let's just combine, let's just collect the like terms. So we got 3x squared plus 2x over x plus 2x plus 1. Now, if we want to, we can factorize out x outside of, that's 3x plus 2 over x plus 2, x plus 1, and there's nothing that could cancel anyway. But I just wanted to make sure, I just wanted to make sure though that whatever I come up with, as I'm simplifying it, that there may be this chance that another factor could appear or something could appear in the numerator that could still cancel with the denominator. So always make sure that you're open to that these kind of things could happen. Now, finally, if I want to, I could just leave it in this form, or I could just express it in expanded form. So I'm just going to leave it in factor form for now. Let's have a look at part H. Okay, so we've got a over a squared plus ab minus b over b squared plus ab. Again, kind of a similar story here, isn't it? So let's write it out in sort of, let's factorize the denominators, because clearly the denominators are not common, so we need them to be common. So that's going to be a over, factorize out a over a plus b minus b over b outside of, now this is going to be b plus a, but I'm just going to write it as a plus b again. Okay. Now, the denominators are almost common, not quite. So they have an a plus b in common, but this one has a b, this one has an a. It'd be good if this one had an a, and good if this one had an extra b there. So let's multiply this one by a over a, and I'm going to multiply this one by b over b. Okay, and let's see what happens there. So we know we're going to end up with a common denominator now of ab outside of a plus b. Okay, so this is now going to be ab, okay, minus ab over ab outside of a plus b over ab outside of a plus b. Oh, this is a nice, interesting kind of result. What do you think happens here? AB minus AB, you get 0. That's a very nice result, actually. It doesn't look it, but I kind of always fascinated by these very complicated expressions, and you think, oh, what? Oh, that's just 0. Yeah, actually it is. All right, let's have a look at 2 more examples. Actually, 4 more examples. All right, so, all right, what about this one? X squared minus 7x plus 10 over x squared minus 10x plus 25 multiplied by x minus 5 over x minus 2. Okay, again, let's factorize out the, factorize the numerator, factorize the denominator, and let's see if we can do some cancellation here, and hopefully everything will sort of come out in the wash. Okay, so x squared minus 7x plus 10, we've seen that one before. Okay, so that's going to be x minus 2, x minus 5 over x squared minus 10x plus 25. That's actually a perfect square. So that's the perfect square, x minus 5 multiplied by x minus 5 over x minus 2. Okay, let's do some cancellation now. So this x minus 5 cancels with that x minus 5. This x minus 5 cancels with this x minus 5. This x minus 2 cancels with that x minus 2. And in fact, the answer is 1. Okay, so nice result there. Okay, part J. Okay, so we have a situation here where we're dividing one fraction by another. We can very easily change that to a multiplication if we flip or invert the second fraction. And let's do some factorizing while we're at it as well. Okay, so what I might do is I might factorize the numerator, factorize the denominator. Okay, so that's easy enough to do. This one's fairly easy as well. That's a, what do you think that is? 4 terms. That's a quadrinomial, so we're going to group in pairs. X squared minus y squared minus, plus x minus y. There's a difference of 2 squares here as well. And you've got x squared minus 4xy plus 3y squared. This one is a quadratic of sorts. So again, let's see what we can do about that one. All right. So let's factorize this one. So that's going to be x minus y. Actually, I'm not sure if I'm going to fit this on here. So in fact, I might just do it underneath here. Just bear with me for a moment. I'm just going to actually, I'll just leave it as it is. All right. So that's going to be x minus y, x plus y, okay, plus 1 outside of x minus y over, okay. Let's factorize this one. So this one's in fact a mnemonic quadratic. So we're starting, the x is the pronumeral in question here. So that's going to be two terms that when multiplied gives you 3y squared, but when you add them you get 4y. So I can think of 3y and y, okay, so, or x minus 3y, x minus y. Okay, negative 3y times negative y gives you positive 3y squared. Negative 3yx minus xy gives you negative 4xy. Okay, and then we're going to multiply that by, okay, flip the fraction, so we're going to factorize it at the same time. So I can factorize out x. So from this one here, x squared minus 3xy, we're going to have x minus 3y over x plus y plus 1. Okay, let's write this again. So we have a common factor here of x minus y outside of x plus y plus 1 over x minus 3y. Okay, and x minus y multiplied by x outside of x minus 3y over x plus y plus 1. And there's quite a lot of cancellation we can do here, in fact. So we can cancel that one there with that, that with that, that with that, and guess what's left? The x. Okay, and this whole thing simplifies to just x. Okay. All right, two more, and that's it. I know this video is quite a long one, but there's quite a few examples that we looked at here, so I think it would really be of benefit to you if you were watch this so far from end to end and just really took in these examples and had a go at these yourself. I think it's good. Right, same sort of deal with part K. You can see there's a difference of 2 squares in the denominator. There's a quadrinomial in the numerator. There's a division which got to turn into a multiplication, and by flipping the second fraction. And there's a basic common factorization we can do in the denominator there. All right, so let's do this. Okay, so again we can take our a as a common factor. All right, m minus n plus 1 outside of m minus n over m minus n, m plus n, okay, and multiplied by 2 outside of m plus n over a minus 1. Okay. All right. Can we cancel a few things out here? Yes, we can, and we can certainly cancel out m minus n there. Okay, so in fact, before I do that, I might just write it here as well, just to save a bit of space. I can take out m minus n, and we have a plus 1, okay, over m minus n, m plus n, multiplied by 2 outside of m plus n over a minus 1. Right, so that cancels with that. That also cancels with that. And so we end up with 2 outside of a plus 1 over a minus 1. Okay. Last one. All right. 1 over x plus 2 plus 1 on x minus 2 plus 1 on x squared minus 4. I think the key with this one's going to be the last fraction there. So this one is really, this is just, okay, I might, in fact, change this one, right? So just to save a bit of space. So really, that's just plus 1 over x minus 2, x plus 2. Okay, so first of all, I've started by factorizing the third denominator, the x squared minus 4. That's a difference of 2 squares. So we have, in the first fraction, we have an x plus 2. We have an x minus 2 in the second fraction. So it'd be nice if these had, this first one had an x minus 2, this one had an x plus 2. So what I'm going to do is I'm going to multiply this by x minus 2 by x minus 2. Second fraction, I'm going to multiply this one by x plus 2. This one also by x plus 2. Okay. And I must put that in brackets there as well. And the third fraction, I'm just going to leave it alone. So what do we end up with then? So we end up with, okay, x minus 2. And that's a difference of 2 squares. So that's just going to be x squared minus 4 plus x plus 2 over x squared minus 4, okay, plus 1 over x squared minus 4. Now we can just add the numerators directly. So x minus 2 plus x plus 2, in fact, that disappears, and we end up with 2x plus 1 over x squared minus 4. And I can tell you from now, there's nothing we could really cancel top and bottom here. That's x minus 2, x plus 2. We can't factorize the numerator anyway, so I'm just going to leave it in this form, and that's it.